When you consider the internal combustion engine has been around for a little over 100 years, actually a little longer than that, to come up with a whole bunch of new ideas that qualifies for a patent from a guy that doesn't have an engineering background is an astounding achievement.
It's not about solving the problem for the next 6 months or 1 year. We're looking at things that maybe won't come to fruition for 10 or 20 years.
The long and the short of it is, unless you have huge resources, it is very, very, very costly to try and develop an engine and a MotoGP bike.
Because the company wants to also be like Honda, which is 50 years old, or Harley, which is 100 years old.
For somebody to come in who has no experience manufacturing motorcycles, starting from scratch with new technology, I think it's going to be
Impossible.
The rules state that the motorcycle has to be a prototype. MotoGP actually comes from the blue-ribboned class of motorcycle racing.
There was a letter, somebody sent me a 2-page letter today about, how I'm a modern-day fool.
I don't think it'll ever happen, to be honest. Not in my lifetime.
How will be the laughingstock of the century if we fail.
He's going against all the odds.
I don't know.
How I'll end up being like a Tucker or DeLorean.
What he's doing is a giant leap of faith, and it's going to be a hell of a lot of work.
It's a big mountain. I mean, it's a big mountain.
You can go out there and ride around, but to compete, you've got to have the backing of the factory.
Everybody likes the David versus Goliath type stuff.
I actually hand wrote on that letter. I thought I'd fax it back to him, then I just threw it away, but it was like, I know the cost of failure, and what I know of that cost is greater than he'll ever imagine.
If you got a bike and you got something that's competitive and you can get it on the track, why not?
I mean, he has no idea what I've risked. I mean, I'll risk my life for this project right now.
This is a guy that took his own money, sat on an aeroplane and decided that I don't have an engineering background, but I can potentially look at something and with a clean slate come up with some interesting new ideas. And he actually managed it.
Okay, clear.
They say it's a fine line between genius and madness. I guess we'll see.
The very, very beginning, it was just me. I probably spent 3 or 4 months on my own.
MotoCzysz is born in Michael Czysz's garage 2 years ago. Michael first imagines the concepts that will become the foundation of his new state-of-the-art motorcycle effort.
It was honest, true, grassroots startup. The hours were primarily after work and at night and on the weekends, so it made sense doing it at home. We did everything here. The bike was built here, the bike started here for the first time, and it lived here, except for the body work. When we started getting into needing to do sanding and stuff, that was just more than this little room could handle. So I borrowed a neighbor's garage down the street and would ride back and forth on one of these little dirt bikes. When we originally had it here, we had, like I said, 4 desks along here with the heater there, and the computers here, and the C1 was here. The engine was built on that desk, the mule engine set in the corner, and we had a drill press and a milling machine and just a few items.
After learning of his son's quest to build a race bike like no other, Michael's father, Terry, joins Team MotoCzysz as chief engineer.
So that I wanted to be there with him and to make it as safe as possible. I know the dangers of the sport. I've seen it for a very long time, and I just wanted to help. Before I was born, my father was into motorcycles, and Specifically Norton's. I walked into this one shop that had a Norton just like this, and it had special signature on the back. It was the original bike that Buddy Perry rode, and lo and behold, CZZ is stamped on the engine.
MotoCzysz moves from the small carriage house to an empty warehouse closer to town. Within these four walls, Michael CZ's dream will be born.
I fully expect us to be reviewing drawings in the next 2 or 3 months, finished drawings in 4 to 5 months, rapid prototype parts in less than 6, and real parts in 7 and 8, and be riding in 9 and 10. You know, we're part of a significant business. We're trying to be a player in a huge show that's already existing. And we've got a window of opportunity that all of us would like to try to take on. And if we do that, we need to have a world-class bike done in 11 months.
Taking on the monumental task of designing, engineering, and manufacturing a MotoGP caliber motorcycle from scratch, Michael assembles a team of brilliant cutting-edge engineers from around the world.
What we're looking for was experience, and we really reached out to get guys with great experience, but we ended up with, since most of the people contacted me first, what?
Together, they will attempt to reinvent what we know of engine technology and build a motorcycle like none other in existence.
Right now, where we're headed is to our machinist, which I've never been to. Oh, did you bring schedules, Federico?
Yeah. Sono Federico Cioni, presidente di MotoCzysz. MotoCzysz è un progetto incredibile, è un sogno che faremo diventare realtà. Seguiteci, fateci sentire che ci siete, abbiamo bisogno di tutta la vostra passione. I was born and raised in Bologna. I worked for Ducati Motor in Italy for 7 years. I will be eternally grateful to Michael for having given me this opportunity. I mean, because he basically hired me on the spot. I went in and he's just like that. We don't talk much. It's really like between us, it's you know, we just understand what we want from each other. I really enjoy the American way of doing things. I really enjoy the attitude. I really enjoy the fact that you never start beaten. You always think you can make it, even if you are the underdog or if you're nobody. We have a big business plan laid ahead for the next 10 years or so. We want to start competing in MotoGP. We want to go there and see, you know, and see how we compete against the big guys. 2 to 3 years from now, we want to be compared to Ducati and MV Agusta. Do you guys need to call Simon in? Simon's here?
Hey, Joe, Michael.
Oh, that's great.
Designing and engineering the MotoGP bike requires major communication between each international team member.
Wow. Monday morning, that's really a big deal here. This might be a big problem. You won't like that.
What's up? No bed plate?
You got a revision in the drawing from Scott.
What? I can't find it. I know we received them, I can't find it. And I can't remember if I actually told us some more. So it's number 341.
I ordered some more.
And do we have them?
Je m'appelle Nicolas Régnier. J'ai intégré MotoCzysz en novembre 2005 en tant que responsable de la conception du train avant et du train arrière, donc des suspensions, et du bras oscillant et de la géométrie de la moto. We are just a small team and we just do everything in-house. Everything is under our own control. That's a big thing. That's a big thing. If you look at MotoGP, it's all Japanese. Ducati is a bit different, but Japanese, they're huge factories with 250 engineers working on those MotoGP bikes only. We are quite a restrained number compared to that. We are very small. It's quite interesting, really. On the personal side, it's very exciting because it's always a new experience. And professionally, whether you work with English or Americans or French, maybe it doesn't change that much as long as people know what they're doing. What I like very much is really the different culture that you have grouped inside the same project. So this is pretty good. This is very exciting.
But we have tracking numbers.
Team MotoCzysz hopes to race their new C1 within 1 year. But first, they have 3 months to present a working prototype to the public, or they risk losing all outside financing and their dream will end. This is no easy task, considering they're building the engine from the ground up. They first must put it through a comprehensive process called dyno testing.
My part is looking after the development dyno testing, and my chief areas of design will be all the internal rotating, reciprocating components. Be involved from conception through to be there when it finally coughs into life for the first time on the dyno, when it first takes to the track, and then when it goes to its first race and hopefully onto its first win. This represents a very rare opportunity to actually be involved from the grassroots all the way up.
Yes, it's nice to be a part of the project that will brings another layer to it, another layer of design in effect. And so it was a great opportunity for us to actually, stretch our wings, I guess, and that was probably one of the largest motivators, that there was this opportunity there for us to bring our skills together.
Do you need to be looking at the one after the signal?
That's what, yes, that's what he said. So directly after the two.
So it has to be a 2 or a...
No,
2 or a 3.
Can you pull 1mm out? Or do you want to make it transparent?
I'm responsible for all the carbon fiber parts, for the bodywork parts as well as the structural parts. From the engineering side, obviously the structural parts are the more interesting ones. I worked in other companies where it was way more difficult to be accepted as a woman in this kind of job. It's very easy here. I think it's more important to have a few people who are really dedicated to their job than to have a huge team of people who are not really dedicated. And I think Michael did a great job to get all the people together.
Truth of it is I really haven't heard anything negative. I think the only thing that possibly worries people is, can he survive? I mean, everybody knows the challenges and the expense that's involved in this. I would estimate a MotoGP team, you've got to be looking at in between probably $50 or $60 million.
Apparently, Ducati had spent $32 million to build their Desmosedici. Honda spent $100 million last year, and will have spent to date about $3.5 million.
It actually started off as the 500cc class back in the two-stroke days.
Two-stroke engines complete the processes of intake, compression, power and exhaust in only 2 strokes as opposed to 4. This gives them more power than the 4-stroke engines used by street-legal motorcycles.
In the 60s, it was dominated by 4 strokes. In fact, it was dominated by a brand called MV Agusta. In about the sort of mid-70s, Yamaha came along with their 2-stroke machines and started winning. Until pretty much the turn of the century, to the new millennium, when really 2-stroke machines were starting to become less popular. Although they're incredibly efficient, they are somewhat environmentally unfriendly. You can't really get 2-strokes licensed on the street, so development of 2-strokes had really slowed down and even stopped. And Dorna, the rights holder of MotoGP, decided that it would be smart to really start addressing the real manufacturer's needs, which was 4-stroke. So they changed the rules, went to 900cc or 990cc, I think, four-stroke machines, and the thing's gone crazy ever since.
For 2007, the formula changed again, and the four-strokes are now running with 800cc engines. The vast majority of motors in cars, boats and motorcycles are piston-driven combustion engines. This engine design was popularized by Gottlieb Daimler and Carl Benz in 1885. This same technology powers every MotoGP bike on the raceway today. As they blaze through turns, the gyroscopic effects of the crankshaft forces the rider to exert extraordinary effort in order to maintain stability in the curves. During a MotoGP race, this battle takes an incredible toll on the rider's stamina. The MotoCzysz C1 has a cure for this with their new counter-revolution Z-Line 4 engine that splits the crank, counter-rotates the two halves, and places them longitudinally in the chassis. The counter-revolutionary engine is an amazing concept. It's brilliantly simple. For Michael Czysz to not only develop his own chassis, but to also develop his own engine is incredible.
The head engineer at Honda said the problem with that engine is you'd have inconsistent intakes and inconsistent exhaust, meaning two intakes would be short and two would be long because of the way the staggering is. Well, we've got around that. We have 4 identical intakes and 4 identical exhausts.
If you can imagine, these two cranks are rotating opposite to each other. So you look at a side view, one of them actually, the power goes into a side gear, which if this is rotating clockwise, this rotates counterclockwise, and the torque tube rotates clockwise.
There must be a whole bunch of people just sitting there going, damn it, why didn't we think of that?
I've raced motorcycles all my life and been around them since I was 7 years old. And I saw this and I thought, how can, in this day and age, someone think that up that hasn't been thought up before? Why didn't we do that before?
It's a very narrow, very thin engine. I think it's thinner than the rear tire.
Because it's a race bike, we like to ensure that we can have a transmission that can be removed at the track, gears changed, put back together quite quickly.
The counter-revolution engine has a removable bottom-mounted transmission. Its ease of access greatly reduces pit repair time. Additionally, the MotoCzysz C1 is designed to be completely customizable and adaptable to each individual rider and track condition.
Each racetrack is different in terms of its corners, what they lead onto, straight or whatever aspect of the track. So it's important to actually ensure that the rider and bike are in a gear ratio that'll get them onto the straight in the most efficient way. So in order to do that, you actually now need to swap out all 6 of the individual gears. Each one of these is a separate piece, so we can change each ratio, anything we want. We can have them all the same.
It's a unique transmission in and of itself. It's 100% designed in-house. All the major components are completely custom designed.
In addition to engine advancements, the MotoCzysz team improves upon other traditional designs too.
On conventional forks, you would have those 2 legs. That would be a cylinder for each of them. And inside those 2 legs, you would have a spring and the damping system. So basically, the 2 legs would have 2 functions. The damper, and at the same time, they would guide the fork up and down. Here we have separated systems. You can see the damper with its spring right in the middle. And on each side, we have the 2 legs just for the guidance. So the functions are completely separated and optimized by individual components. So basically, when the suspension moves up and down, inside there, you have this inner tube, this outer tube with some flat faces on the inside also, and between you have linear bearings. Linear bearings with rollers. They are very strong to cope with the load under braking.
The front end he's developed, his slipper clutch, the way he's laid out the motor, the rear end geometry he's got going. I mean, there are significant reasons as a racer that I can see that thing leading the world.
MotoCzysz has approximately 20 patent applications on file. and we have about 10 that's just sitting there waiting to be written.
Before MotoCzysz can become a fully self-sustaining company, they must secure venture capital by proving that the cutting-edge technology in the C1 motorcycle actually works.
What I definitely want to do, Simon, is have them put another shield in this area, 1/4 inches with 2 little standoffs. And that'll help a little bit.
I've never invested in a startup in my life, but I became very impressed with Michael and his ability when I started researching what he'd done with his life and then his commitment to this project. I believed he could do it.
With only a couple of months before the public unveiling, Team MotoCzysz must push themselves to turn their design dreams into hard reality. Armed with designs to build the most advanced motorcycle ever conceived, Team MotoCzysz prepares for their public debut. If the C1 proves to be MotoGP worthy, Team MotoCzysz will secure financing into the future. If not, their dream of changing the motorcycle world will never see the racetrack.
It's from Jim. Okay, I'll see you in a little bit.
He's a great student of the market and a great student of race technology, and he has tremendous passion for motorsports and great commitment to his own ideas.
There's a lot of passion at the origin of that project. It's not, it's a huge hill to climb to build from scratch a MotoGP bike to go fight the top factories. But that's also what has been moving a lot of the racing industry. And to do that by using revolutionary concepts, I think those are pretty much the 2 defining concepts behind this project, passion and revolution.
As far as the resources he had financially to complete what he wanted to do, I still thought that that was going to be a pretty daunting task, but when I realized his true vision and how passionate he was about it, I thought, okay, all he needs is a couple breaks and he'll get there eventually.
It all looks cool and it all looks fun, but right now it is an absolutely nightmare.
Without a working engine, the bike can't be assembled. The situation is critical.
We can't really do hardly anything until the engine gets there because it's a stress member and it is a big part of the frame. So effectively, you really only have until the 22nd at noon to do all of it.
Now that we know the program has told us what size tool we can use and still clear going inside, now we don't have the proper tool, and it needs to be at least 5 inches long, and we need to be able to turn it back. We don't have that in stock, and I don't know if anyone here locally does. So we'd have to red it in. That's worst case. But being it's after 5 o'clock, we can't call anyone.
Hey, Jim, Michael, are you still at the shop? Okay, we're having trouble getting through. We need to have Simon go to Scott and have Scott make a dummy valve guide. So okay. Yeah, it's an impossibly short period of time. I mean, when the bike comes together, even if it comes together perfectly, it is in a complete raw state. The next 2 months after Laguna needs to all be spent on, or as much as possible, on development. All you can do is just make the bike as rideable as it can be in that period of time and go with what you have and just hope that it's enough that, you don't get lapped.
With 34 days until the first public showing of the C1, the team tests Nico's new suspension elements by attaching them to an MV Agusta. The team is on edge as they await the results of the first real track test of the unconventional MotoCzysz suspension design. Any mistakes could mean severe injury or even death to the rider. And in this case, it's Michael Czysz.
Today we focus on the bottom end of the front suspension. He'll push the bike as much as he can. You have a very long straight. End of the straight, he'll be at about 270 kilometers per hour, which makes it 170 miles per hour. One lap time will be 1 minute 13 seconds.
Because you'll never run lighter than this. I mean, this could be at the bottom of the range, to be honest.
Again,
I'll do, yeah.
Yeah, we're locked.
Not on the rebound, yeah.
No, the compression.
But Nico, I'd make the compression the first setting next time.
We should send all the 3 shocks back and have them in various stages. Oh, we only have 2. Okay.
Yeah, because we missed a bracket.
We're changing weight distribution, so we're loading the front end a little bit more, raising the rear. That gives him a better feel on the front end.
Unfortunately, the whole bike is higher than it was, and it's a little tippy. Yeah, same attitude. To be able to drop it, we can't drop the front on this bike anymore, so we had to compensate by raising the rear, which raised the entire bike up.
He's going way faster. We did a little bit of adjustment on the rear, and that made him more confident on the front. So he can push a little bit more on the front, which is a good thing. You can just feel that he's pushing a bit harder, so he's more confident into what he's doing. But only the feedback will really tell us how he feels, basically. You need to talk to the rider for that.
What's up, big man?
How are you?
Good. Kagan, is this the same setup we had in the rear last time? Yeah. It seems softer. It was hooking up like crazy. You have to have apex speed to have that thing compressed before you really start feeling how it moves.
Yeah, and he doesn't feel much difference between the 2 springs, whereas you do.
Yeah.
Which probably means that he's not pushing well enough yet mid-corner to really get that. Indeed, I think it was a very positive test. Not everything was perfect, technically. I'll go into the details. But I think it was very positive by the quality of the feedback we had. The front end, Michael found an adjustment that he liked very much. This adjustment is about the trail, basically. That's the main thing. He's not so happy about the ride height, but we can modify this pretty easily. Negative point was the shock, the front shock, that is not ready yet for what we need. So basically for those parts that will happen between Michael and I will do the changes myself.
Standard cylindrical forks are limited in the amount of flex they give the rider while in the turns. The MotoCzysz unconventional fork design adds more flexibility and control to the suspension system.
Quite likely it's going to flex a little bit more than the part we had before. If you look at the blade, the section of it, this part here, is not a circle. So this dimension here is way longer than this dimension here. So that's how you can control the flexion differently in 2 directions.
Normally in any kind of testing or any kind of development, there's normally no big, like, Shazam moments. It's normally little bitty steps to reach to an end goal.
Only days from their debut and test ride, Team MotoCzysz works with little to no margin for error. Everything must fall into place perfectly to be ready for the first public showing of the C1.
That'll actually help the wheel.
Once he has something that he likes, design-wise, engineering-wise, just, you know, looks and everything, he'll actually bring the sketches to me, show me exactly everything that he's done, how he wants it to look. Then I'll transfer all his information onto CAD, onto SolidWorks, and then I'll model it up, make sure everything works, go over it with him, finalize some details.
In a perfect world, it'd be like this. And you could look at that if you want, which means the flats would be out there.
Right.
But it's going to be quite,
just be small.
It's going to be really small. And I don't know if it's going to add, you know, we're great here.
Now these are counterboard. Maybe we can spot face those or whatever, clean them up to get a better face to mount that bracket on.
That'd be great. 3 weeks away and we're still kind of don't have the bottom completely resolved. Finish design, go into CAD, get cut and laid up all within days. An unbelievably concentrated amount of time.
Nico has relied on outside vendors for work on the suspension parts, sometimes with mixed results.
This is the new swing arm. It's made in aluminium. What you see here is a jig for the welding, but the swing arm is this big aluminium part. It's made out of 6 parts, which are the legs, one on each side, the cups, one on each side, and the middle parts, which you can't really see it anymore. Actually, maybe you can still see it, are welded together in the middle. Unfortunately, those parts in the middle are not exactly like what we had specified. The reason for that is that when we welded everything together, those parts in the middle started to crack badly, so bad that we know we will not be able to use this swing arm. The cracks I'm talking about, all the welds have cracked right in the middle. This is not supposed to happen. A weld is supposed to be really beautiful like this. This is a sign that the material is too strong and too brittle. At this point, we still don't know what is the cause of this, and we need absolutely to make sure that this doesn't happen again to the next swing arm, because we have only one chance now to have it right for Laguna Seca.
The second attempt meets with Nico's approval.
This is a new one, so it's all been brushed, and now it's all beautiful. We just have to do the post-machining and then powder coat it, so paint it black, basically. The welder did a beautiful job here to make it really smooth and really beautiful, so it's quite pleasant. The good news is that it's 4.5 pounds lighter than the one you've just seen, so that would be a compensation, but it's still a very, very good start. I'm pretty pleased with that.
A major element in the design of the MotoCzysz C1 is the carbon fiber outer shell. Making the carbon fiber as light as possible without sacrificing strength requires patience and concentration throughout the molding process.
On Monday it became quite hot, so we had kind of troubles with the layup to do it early in the morning or late in the night, because during the day it was about 90° Fahrenheit and more, and that's not the temperature you can have when you do a carbon fiber layup. Simply because you brush on the surface coating, and the surface coating still needs to be tacky when you start the layup of the rest of the carbon fiber. So it started to react too quick because of the temperature, and it was quite tricky to get the first layer in before this is hardened. Because if it's hardened, you don't get a perfect connection between the surface coating and your layup. it's always the first part is the hardest to unmold, because you don't know 100% where's the right point to pull it out.
Well, I walked in there and I was all like gingerly and trying to just take my fingers and lift up little corners of carbon fiber, and I saw particularly the girl Germans on the table with huge like channel locks and pounding and banging on, and a half hour I lost my sense, I got desensitized. The thing that we were most eager to see was this whole shape. I mean, there's a lot of design going on, and we wanted a very aggressive but fluid shape, hard but soft, all those kind of, the dichotomy is when you talk about design. And it came out just spectacular.
There were some areas where it was quite tricky. It was not that it was sticking in the tool, it was just you have big areas where it's not so stiff, and you have the ribs where it's quite stiff. Actually, it's stiffer than I expected it to be.
Yeah, so this is the right-hand fairing. So the rider basically is in this area. There's another one on this side of the windscreen there, and this is the cockpit area that you work from. And in fact, of course, the rider is basically like that. There's, of course, more panels and trims and cutouts and, tons of work to do. But this is amazing stuff, how light it is, just absolutely how strong it is. It's not like we're making big flat panels that can pop out easy. So, we could put more splits in the mold, but Andre is an absolute perfectionist.
Days before the public unveiling of the C1, Andrea is under incredible pressure to rush out a finished carbon fiber frame. Because they're short-handed, she's been forced to farm out one of the key tasks, and it's not up to her standards.
Looked at this, they said, okay, if I would have done this, you would have fired me. And unfortunately, it's true, I wouldn't have accepted something like this. If you look on the fiber direction here, you would have a visual direction with a perfect layup like this. And it's actually like this. And a few degrees of changing the direction of the carbon fiber makes a lot of difference in the strength. And these are just things that make me worried about everything, because I don't want to kill anyone. I prefer to be an than to kill a person riding this bike.
And that's just the nature of making the part to the standards that we want to make them. The last schedule showed that the engine should start being assembled today. That was already some 30 to 60 days from what we wanted at the beginning of the year. But then we just had another slip the last couple of weeks, so we're supposed to start construction on the engine today. It'll actually start on Friday. We'll keep our fingers crossed that happens. And if that happens, that's literally, it's down to days and hours on how long we have to construct it, to mock it up, to dyno test it, to take it, tear it back down, put it back in a bike, chassis test it, tear it back down, and then take it to a track.
With the engine build falling further behind schedule, Adrian goes to check on the monoblock status.
I think the realization that the original deadlines that we had hoped for and the milestones we had hoped for post-design and post-prototyping, when we were actually to start doing track testing, just got completely delayed and completely derailed. It's not a reflection really on the team. It's not a reflection on, we made some bad choices and bad decisions and there's some faulty concepts. I mean, those are still yet to be proved out. We may have done that. We don't have an engine that we can run at full speed, and we don't have an engine you can run at full speed. You just can't do anything.
As soon as we get back today, we'll bring in basically the finished article from the machine shop. We will have 4 more liners to press in, and then there's a skimming operation just to clean those off, and then that is it, ready for build.
Production Tool Manufacturing is a manufacturing firm, and we got hooked up with MotoCzysz through a local tool guy. once they realized who we were and our technical ability and our capacities, not a small shop and not a large shop, but right in the middle that could handle their prototyping in the onset and flexible with their schedule, certainly we're committed to that. We were awarded the monoblock.
Getting very close to being finished now. It's a few more operations, a few more assembly operations of the bore in here for the crank, bore down the bottom for the torque tube, and then another bore here for the idler gear and alternator. Then that's going to be finished. It's pretty good. I guess, I mean, how do you inspect? You can't, can you?
You can check with minor diameters and major diameters next year.
That's about what you can do, isn't it? But in terms of its runoff.
Woo, that looks just like the drawing. Yeah.
It's great. It's the first time I've seen them together, actually, machined. So yeah, it's looking good.
Adrian rushes the engine monoblock back to MotoCzysz for immediate assembly.
After 2.5 months of wait, we finally got our monoblock in. So it was a really great day. We were all excited because it looks beautiful.
That's really good. Yeah. Well done. It's a good day.
It really does.
With all the work that has been going on, it was kind of finally, it felt like that finally something was going to start.
We've seen it through all the steps. You know, it was first sketched out 9 months ago. Seen it in the modeling, seen it in the CAD drawings, seen it in rapid prototype, and we've seen it in the castings. It's just, we've just been so much anticipation waiting for it to get here to stage where we could start building it.
Looks very good.
It really does.
Although the machining work has been done to perfection, Terry Sears discovers holes in the original casting of the monoblock.
It's right under the seat. You can see the crack. Yeah, right there.
Oh, that's a huge problem.
That's a big problem.
Fortunately, we figured out that the monoblock was leaking pretty badly. Just a big mess.
What I think we should do is take and put this in water. Okay.
Definitely. Absolutely.
And then we can tell if we have other problems.
Fortunately, we could not use the monoblock as it was.
Sink up in the bathroom.
Mm-hmm.
So we went from a peak down, we plummeted down to a big valley.
See if we can plug this one up, because if
Actually, I don't have any use.
With the debut only days away, Team MotoCzysz scrambles to find a solution.
I machined identical. But
I think the time and energy put into this trying to fix it would be better put onto another one.
Michelle doing the second
Right.
one.
Yes, you stop her from going forward.
Now, the only thing that you could do is perhaps take it to Frank because he does all this stuff.
Who wants to run over there?
I'm happy, I know where he is. So
Why
let's
don't you
give
do
him a
that?
ring and do it. And yeah, I'll take it over now.
Just take it exactly
Drive
the way it
off
is.
and, yeah.
Yep. It's a good idea. Honestly, if we can find the guy who cut the seats, to be able to yank them out, weld it up, and cut them back in, but that's...
We need the new block as fast as we can have it.
Well, but if we can fix this one faster.
This is not a for sure fixable solution. This is a backup plan. Okay, the way I see this is a backup plan. The real solution is getting a real block.
Yeah, but that's going to be 10 days from now, so it's impossible.
Once the fixture came off of the block, we lost all our reference points. Yeah, no, it's a bit of a setback for us, that's for sure.
We had a number of leaks between the valve seat and the casting, so you could witness that as an air bubble coming out between the two of them.
People running around looking for blocks, and it was like, what's going on here?
Then just literally went onto the internet with the mil spec and tried to find someone that was as close to Oregon as we could that did the process. That turned out that there was a company in Oakland, in California.
Simon flew down with the engine all wrapped, with the monoblock all wrapped in bubble wrap. He knows that there's a company in San Francisco that does stuff for the military, and they can infiltrate the monoblock with some ceramic coating. So effectively, they put some liquid into these cracks. They suck it with a vacuum system, and then it sort of like solidifies and cooks in the little cracks. So it fills the cracks with ceramic.
The costly process of filling the cracks in a precision engine puts Michael and his company in a deep financial bind. He contacts the casting manufacturer.
Hello, this is Mike.
Hi, Mike. Michael Sis from MotoCzysz.
Hi, how are you?
Well, I'm all right. Could be better. All right, let's just get into it. So we received the block. We took it over to Michelle. We did our initial inspection. There were some areas of surface porosity. We really thought it was probably just air bubbles. That looked to be the case. We were pretty optimistic. We dove into it, and after 2 days of machining, we've come up with holes that you can literally stick your pinky into.
Prior to coming to MotoCzysz, saw a large number of castings over an 8-10 year time span. I've never seen anything like this before. I've certainly never seen anything as bad. I want a casting that is 99.9% aluminium, not 90% aluminium and 10% holes. It's clearly unacceptable to us. You know, it will cripple the company if we can't find some sort of resolution to it. There's no way that you're going to put something as compromised as this into a bike whereby if there are any issues with it, either catastrophically because it has failed and you put a rod out the side of your block, or in any other fashion and it dumps all of its coolant or oil onto the back wheel where clearly you're going to put the rider down. Nobody wants to put anybody into that position. We would choose not to put anybody into that position.
To me, I don't think we can keep going down this path. We need to be reimbursed for the machine time that we spent on these blocks, and we need to go someplace that has already done this type of work. But I need to get reimbursed on the work we did so I can go someplace and get 2 engines built. Otherwise, we're essentially done.
Team MotoCzysz receives their repaired engine. However, there can be no guarantee that the ceramic process plugged the holes. Only by putting the engine on the dyno tester and starting it up will they know for sure that it's ready. If it's not, the engine could literally blow up, taking with it the MotoCzysz dream.
Whilst there are no guarantees, it certainly looks inordinately better than it did before, and we've been able to negate any excessive machining or welding processes. So we'll find out when we get on the dyno. Whatever happens, if there are small leaks, we can live with it.
It's not wanted, but it is normal for these things to happen, you know. First off, castings can be a bit troublesome. It's just a problem, you've got to solve it and move on to the next one. You know, simple as that. So we probably lost another day on the build.
The very nature of this thing is all problem-solving, emergency, solve, and repeat.
The engine has now gone through its dummy build, first build, which is just to check everything out, everything fits. We've had a reasonable amount of issues with the castings being a little bit off and the machining not being particularly accurate. So the actual build's been a little bit painful in terms of you have to fit everything, check it all rotates, take it apart, clean it up, etc. So that's been done, and this is the actual final assembly that you're seeing here. This is how the engine is going to run when we hit the dyno. I believe we're just waiting on an O-ring for this transmission to go on. Then that will slide under the bottom of the bike. And we're waiting on the cam cover as well, which is being machined at the moment in our machine shop. And I believe that is it. We've got a rapid prototype cam cover there that we can use while we're waiting for the main cam cover. It's like a resin impregnated with like a super glue or a Loctite. Actually, it's a glass-filled resin, that's right. It'll take about 120 degrees C. It'll withstand the oil, so we can actually use this to run. just for the first crank over of the engine while we wait for the real piece. Hopefully we don't have to do that, but if it comes to it, we will. But we weighed the engine the other day. It's so light. It really is impressive. It's a lot lighter than I thought it would turn out. It was 125 pounds, which is really light. I'm very impressed with that.
So it means the bike will actually should be underweight.
We are getting there, you bet. So putting in some weight hours and trying to get everything addressed as we go. So it's looking pretty good.
I think I'll do this before we set the difference.
Running down there to give it clearance for the gear. You see this radius?
Yep, go straight down.
Well, not straight
As the deadline approaches, many team members stay awake for days at a time, working to prepare the engine for the dyno test.
I got home about 3 o'clock last night and slept in until 9 o'clock this morning. So, charged, ready to go.
If we were to take an engine straight out of the build shop, all right, what are we going to do with it? We're not going to stick it in a motorcycle frame because we need to verify, first of all, that it will start and run, that it will, make a reasonable amount of power. We need to verify that there's nothing wrong with it. So what we're going to do is stick it on a dyno, very similar to this installation here. First thing we're going to do is fire it up and make sure it idles. And our idle on a race engine is going to be significantly higher than you might expect on a street bike motor. We're going to go straight to 3,000 or 4,000 RPM on this. In conversations with the former Cosworth engineers who designed this, Simon and Adrian, their target horsepower is in excess of 200 horsepower. This is reasonable in their estimation based on their experience with racing engines from Cosworth and by careful observation of competitive horsepower from similar MotoGP engines. There's going to be varying degrees of success. I think this is going to be a sliding scale, if you will. On this first engine, for the bike that has to go to Laguna, I'm going to be happy if the thing lives to 10,000 RPM. I am not at all concerned with horsepower at this point. I know that Michael has invested a lot of his energy and time and emotion in this project. I don't want to see this thing wrapped up in a single number.
In a standard engineering process, bringing up an engine like this and of this complexity, you would like to see a schedule and a test plan that assumes you're going to have to iterate on this, right? So you take some baby steps, you think you're going to make a partial power run, you're going to tear the engine apart and verify that you're not damaging it in any way. And then, you approach the target gradually so that you can sort of minimize any catastrophic failures that might occur. We just don't have that luxury here. We have to choose a path that will lead to success, and we don't really have the option of iteration at this point. So it's a risky approach, but ultimately is really the only way that we're ever going to get successful at this. So we have to get the engine on the dyno. It has to make some power. And if it doesn't, if we have some setbacks, well, we're not really in a position to plan for that at this point.
We're almost ready for the big bang.
With less than an hour to first engine start, the crew has not slept in 3 days.
What do you mean, soy?
So getting the swing on earlier doesn't really matter. That's cutting in too close for my comfort.
Yeah, pretty sight, isn't it?
You're welcome.
All right, we've got a coolant leak coming out of your stellar plumbing job there, Adrian. As a plumber, you make a great beer drinker.
Do we need to tighten him up? No. Hang on one second. There we go.
No, I don't. Yep, the male, female
If we can sort it out, great. If not, don't worry about it. Thanks, Chris.
Bad news having a black shelf got carbon, you know.
Oh, I'm sorry. 1 and 3 are, yeah. Right.
That's in sixth gear.
Well, you have to go back in there.
Probably not enough work, yeah.
It looks really...
Where's our voltage on the starter? What's the voltage?
Did
you change it down in a second?
Are we still in first gear?
Not changed it.
I didn't change it.
No, no one's changed anything.
After months of anticipation, the moment to fire up the engine has finally arrived.
Oh,
An engine fire threatens to torch the hopes of everyone in MotoCzysz. They must now decide whether to continue with the dyno test and risk destroying the engine or go back to the drawing board.
Put it in first gear.
Well, if we had a torsional vibration in the crank coupling that we were not easily able to account for in the initial stages of the design, we could quite realistically split the whole engine apart on the dyno as we pass through an engine speed operating point. This would be devastating to the program.
Correction.
Okay, so what are your pulse widths going to be at this point? Are we in the 1 to 1.2 millisecond range?
No, about 0.5.
But that's probably just on the borderline of cracking those things open.
No, but that's the.
That's the effective pulse width. Okay, so you've added in the turn-on time. Okay.
The turn-on time.
We may be mis-synced. We're not getting anything.
Realizing they have but one choice, they push to start the engine.
That's awesome, man.
Yes!
I will do it in a minute.
Duplicate the start
All right, Dad. See you tomorrow. Sleep well. I think I will. Until we race, it probably doesn't mean a lot. But what it did mean was we were able to build a bike, design a bike and build a bike in 9 months. And, you know, we hit that deadline.
We put the last penalty against France for the World Cup final. The same exact, it's like I won the World Cup twice this year. That was the feeling.
Quite an unpleasant birth for the engine.
Lack of dyno control.
I think it's one of the coolest looking bikes out there, and it's so nice to see a fresh mind like his. And it's kind of like this. Michael, ballsiest move I ever seen, man. That's right.
I know you guys.
How you doing?
It's my father, Terry, Ben, and Norm, Adrian. So they're gear driven up on one side, and it's a triple overhead cam because we wanted to make the intakes as narrow as possible, keep the package as narrow as possible, but have the things as straight as possible. Thank you, Ryan. What happens is our intakes actually go between, if you take a look there, the throttle bodies go between the intake and the exhaust cam.
It dumps it straight down, huh?
Dude, straight freaking down. And what's cool about that, when you have all four of them there, they sit in this absolute wonderful, gigantic air box. Remember, it was fed with those two air ducts. Comes right in. The air filters are this long on either side.
MotoCzysz, having built a bike from the ground up, has had to design and manufacture more than 1,000 custom parts for the C1.
Yeah, it's got some pretty pieces. 215, 225 engine. This may be the best slipper clutch in the business. It's actually electronic hydraulic clutch.
It's the most expensive machine I've ever been around.
Totally, absolutely guaranteed.
Getting to touch them.
You know, you have to like see it to believe it. It's one of those things that to actually see it happen. You've seen special bikes made here and there, but they weren't raced on this kind of level.
First impression, definitely on a cool factor scale of 1 to 10, it's a 10.
And the most exciting part would be the fact that they've started from scratch. You know, I think if any of us took a bike, we would start with an idea that was already there and say, man, a good idea to modify that. But no one's going to sit there with this blank piece of material right here. So let's just start building something. So it's almost like when you look at the Japanese bike or the Italian bike, they're completely different. It's crazy. But to think that there's a whole third train of thought with this American bike, it's really ground up and outside the box thinking. It's unbelievable. It's gonna be good.
The bike's beautiful. I guess on the scale of the undertaking of the task ahead is got to be a 10 as well. I mean, for one man to try to put together something like this it's really amazing.
After months of effort, the time to debut the MotoCzysz C1 has finally arrived.
Being at Laguna with our new bike was instrumental for us in many ways. I mean, we probably couldn't survive if we didn't show up.
The team gets the C1 together just minutes before the unveiling. And finally, the C1 has its day.
Ladies and gentlemen, the new MotoCzysz.
I'm willing to take a couple Q&As. We were told we couldn't start the bike, but I'm kind of willing to give it a shot.
We did it, and we met with the people that we wanted to meet in order to pull our plans forward.
I do not know of anybody that would even come close to wishing Michael Sears anything other than absolute success.
6 months ago, we could have ceased to exist 6 months, which would have been today. That hasn't happened. And it continues to grow and get stronger and stronger with momentum.
For Michael and his team, an important milestone is accomplished. Now, in order for them to secure future funding, they must prove their concepts where it really counts. They take 2 C1s, a black bike and a silver bike, out onto the test track.
To actually see it go around the track, that's a nice point to get to.
We've only run it up to 10,000. Wow.
There is a washer in the engine, a fairly complex washer used to hold the torque tube together, that had some pieces crack off of it. The pieces fell down into the oil and subsequently got sucked into the oil pump, where they bound the pump up and sheared the drive. At that point, the pump stops turning and potentially causes catastrophic damage to the rest of the engine. Well, I am hanging out on the front doorstep of Lawless Engines, right in front of the sign that says open at 7 a.m., and it is now 7:45. So, no evidence of this guy showing up yet, and he's not answering his phone. We got nothing. We could have wiped out every bearing in the crankshaft and the transmission. If we looked at the data, we could see that when the oil pressure dropped off, clearly indicating the pump sheared. And at that point, Michael saw a warning indicator on the dash. He was concentrating on other things, obviously, so the bike continued to run for about 24 seconds after the oil pressure went zero.
Team MotoCzysz is forced to make repairs in a matter of hours that usually take days to accomplish.
Exactly. I'm going to have to spot base in both locations because it's going to be right on the edge.
So we'll use the same end mill for both ops?
Yeah, that's what I was going to do, is basically spot, turn, spot.
Okay, so we're basically held up until those things.
Yeah.
All right.
If they're wrong about any of their adjustments, the result could be serious injury to the rider.
Closing the valve. Okay. Right. All right. Bolt it up and see if it still works. Right. So what we're going to be doing is stroking the clutch through its travel. I'll keep the valve closed, and we'll see if we keep the clutch in its disengaged position.
It's kind of wobbly. It feels like the pegs are real far forward, and the seat and all is disconnected to the rear.
Creator and test rider Michael Czysz and the MotoCzysz team must test the bikes to the edge of their limits to get the critical data that they need.
Sounds wicked, mean. I really hope it doesn't crash.
This is a scary test right now. We've raised the rev.
If I just mess up at all and run to the corner, it'll start chattering any point. As soon as it starts chattering, it just, runs so wide. So I'm not aggressive going in at all.
It's the front end tying other than the damping?
Yeah, I think so. I think the damping's the biggest problem, and then of course, chatter.
This is not really surprising to me. These engines are still in development, so there were changes made on the black bike that aren't present on the silver. So they are essentially different in some subtle ways. And we've also got different cams, so the torque curve is going to be different.
not surprising. It just points to the fact that we have to develop these two bikes separately.
Emotionally and personally, I told everybody this is a one-shot deal. We have one shot to do this.
Yeah, if you actually feel like you're on the back foot, you're going to be on the back foot mentally. So we came here, the whole team, with a lot of confidence. I think the entire team has an awareness that it's vital. You know, if we don't perform this, we will not get more money and we can't and move into the production aspects of it.